Students, so we are doing some physics numericals. Question is, an armature coil consists of 20 tons of wire, each of area 0.10 meters square and total resistance of 25 ohm. Okay, it rotates in a magnetic field of 0.5 Tesla at a constant frequency of 150 upon pi Hertz. Calculate the value of maximum induced EMF produced in the coil. Now this question is based on the AC generator. Okay. So the maximum induced EMF is given by the formula EMF induced N B A omega, that is angular frequency, right? So first you write what is given. So N is given as 20 tons. Then area is given 0.10. So you can write it as 0.1. Okay. Total resistance is given R, 25 ohm. Then it rotates in a magnetic field 0.5 Tesla. So B, magnetic field, is given at a constant frequency. So F is given 150 upon pi Hertz. Okay. So how we write angular frequency? 2 pi F. So substituting values, N is 20, B 0.5, A 0.1, 2 pi into F is 150 upon pi. Okay. So we get this as 15 to the 30. So 300 into 20 into 0.5 into 0.1. So I'll write this as 5 upon 10 and 1 upon 10. Okay, so 100. 25 is 100, 100 into 3, 300. Okay, so this is EMF, it is in volts. Okay. Next is we have to calculate maximum current drawn from the generator. So here resistance is given, right? And we know the voltage, that is EMF, maximum voltage, maximum induced EMF. Okay, so we can find the maximum current. So how we write? Using Ohm's law, V is equal to IR. So I is V upon R, correct? So I maximum upon R. So 300 upon 25. Okay. 12 ampere. Okay. And one more sub question is there. Average induced EMF produced in the coil, it is 0. Okay. As we know that EMF produced here is alternating. Okay. Next question. A magnetic flux of 50 milliweber is produced in a coil when 5 ampere current flows through it. Calculate the self-inductance of the coil. Okay. So this question is based on the self-inductance, right? So how we write the magnetic flux in terms of self-inductance? Phi is equal to Li, right? What is given? Magnetic flux is given 50 milliweber. So we can write it as 50 into 10 raised to minus 3 Weber. Okay. Current is given 5 amp. We have to calculate L, that is self-inductance. So phi is equal to Li, right? So L is 5 upon I. 50 into 10 raised to minus 3 upon 5. 10. 10 into 10 raised to minus 3. So this is 1. 1 minus 3 is 10 raised to minus 2. So we'll get here 0.01 Henry. Okay, this is self-inductance, so unit is Henry. Next question. The magnetic flux threading a coil changes from 12 into 10 raised to minus 3 Weber to 6 into 10 raised to minus 3 Weber in 0.01 second. The value of induced EMF. Okay, so how we write induced EMF? Minus d phi by dt. So this is change in magnetic flux with respect to change in time, right? So here two magnetic flux values are given. So first it was 12 into 10 raised to minus 3 Weber, and then it changed to 6 into 10 raised to minus 3 Weber, and then time is given, that is dt is given 0.01 second. Okay, so this is change in this, we have to write phi 2 minus phi 1 upon dt. So I'll write it here. 6 into 10 raised to minus 3 minus 12 into 10 raised to minus 3 upon 0.01. So this we can write 6 minus 12. I'll take common 10 raised to minus 3. So minus 6. So it becomes plus 6. And this is 0.01. So 1 upon 100, right? So 10 raised to 2. So when it goes in the numerator, so we have to write 1 upon 100. So here it will be 10 raised to 2. 6 into 10 raised to minus 3 plus 2 is minus 1. So this is 0.6 EMF. So voltage, volt. Okay. Next question. A magnetic field of flux density 10 Tesla acts normal to a coil of 50 tons having 100 centimeter square area. Okay, find EMF induced if the coil is removed from magnetic field after 0.1 second. So here we have to find the induced EMF, right? So induced EMF, how we find? We want a magnetic flux for that, right? So we have to make use of this given information to find the magnetic flux. What is given? Magnetic field of flux density 10 Tesla. So this is given in Tesla. So we know that magnetic field is 10 Tesla. Okay. X normal to a coil of 50 tons. So N is given 50. Having 100 centimeter square area. 100 centimeter square. So we have to convert this to meter. Okay. 1 meter is 100 centimeter. So we write it as 10 into 10 raised to minus 2. Correct? So here centimeter square is given. So we have to multiply by 10 raised to minus 4. So this becomes, this is 10 raised to 2, 2 minus 4. So minus 2 meter square. Okay, and change in time is given, that is 0.1 second. So here two cases are there. First is when the coil is in the magnetic field, right? So the magnetic flux will be what? That is when it is in the magnetic field. So this becomes our initial magnetic flux. It is given by NBA. So 50 into 10 into 10 raised to minus 2. So 50 into 10 raised to, this becomes 5 into 100, right? So 10 raised to 2. 2 minus 2, 0. So 5 Weber. Okay. Now when magnetic flux, when coil is removed from magnetic field. So here we'll get the value 0. Correct? So we have to find EMF induced, it is minus d phi by dt. Now change in EMF, phi 2 minus phi 1. Phi 2 is 0 minus 5, 0.1, phi upon 0.1. So this is 1 upon 10. So we get 50. Okay. Volt. Next question. A wire of length 0.1 meter moves with the speed of 10 meter per second perpendicular to a magnetic field of induction 1 Weber per meter square. Calculate induced EMF. So here speed is given, length is given. Speed, length is 0.1 meter. And this is magnetic field is given. Okay. So we have to make use of the formula EMF equal to B LV, right? B is 1, L 0.1 and 10. So this is 1. EMF induced, so volt.